Great, thanks, Phil. So first of all, I'm glad that we're able to do it. The AV person just told me, you'd be all right without your speaker notes? And I told him quite clearly, no, I will not be all right without my speaker notes. So yeah, good morning, everyone. Really pleased to be here at ComSum. This is my first talk at ComSum, but it's also my first in-person ComSum event, apart from the after parties at the summit. So very different to be here today. So, dude, where's my Lambda? Now, a lot of you probably quite rightly asking, what on earth are you doing? We've got a great event here. We've got some really fantastic speakers. There's an awful lot to take away. There's some really great insight, valuable insight. And here I am with appalling Photoshop skills and some really bad pun work. So what I'm going to do, and to give you an understanding of why we have this Dude, Where's My Lambda talk, you'd be pleased to hear that we'll go into a bit of my background as a developer and how I've come to really love and embrace serverless. So here we have the slide deck that no one cares about and generally want to skip through fairly quickly. So hello, I'm Misiukanis, principal consultant at Steamhaus, based here in Manchester. I'm a reformed developer. 20 plus years experience, initially web, e-commerce, that kind of thing. Around 2016, I started my AWS journey. I'm a serverless specialist, so essentially I work with teams and I look to enable them to do more while handing stuff over to AWS. I'm a huge fan of not writing any code, and the key part, I think, is the reformed developer. That's essentially where we get this takeaway from. And I spent years actually writing and developing applications. So my early journey it starts in what I describe as the Wild West. So it's just after the dot-com boom. There was an explosion in online business. Everybody is scrabbling to get online. I start with PHP, just a jumble of everything. Complete mess. So there's no deployments. There's FTP to live servers, of VMs, or shared hostings. If you're lucky, you might get a dedicated host if you're a big enough client. Testing, no, absolutely not. Not even a second thought to it. Version control, no. We've got .old for that and .old. Routings, maybe we could use file names. That'll work. But the thing that is interesting for me, and this will be a theme I'll come back to, is that I think technology is kind of democratizing. I've said it before, I've said it a lot of time, but it's this idea, it's no longer the preserve of clever people in laboratories. Anybody who's got an interest, got some time on their hands, can start building things, start getting online. And that was really where I started out. So next, if we look at my teenage years, as a developer, I am starting to do things. I've got dev practices. I'm using Git. I can write tests. Doesn't mean I'm going to, but I can do. I'm starting to use frameworks. And what those frameworks are doing, they're great because they're reducing some of the stuff that I used to do. So they're taking some of that grunt work. I might be installing dependencies or using packages that someone else has written that I'm now standing on the shoulders of, and I can say, well, I can configure this myself. I can start handing some of that work to someone else. I'm abstracting that code away, but I'm still in control. Still me making the application. I'm just letting someone else deal with some of the stuff that I don't really want to, and someone else has probably done a better version of. Get to the part of careers where everyone is either at, has been to, or has pushed through, which is the part where you think you know what you're doing. So at this point, I'm reasonably senior, not massively senior, but senior enough to make decisions, to decide how we're going to build applications, how we're going to code those applications. I start working in AWS, or working with AWS technologies. To begin with, not a great deal changes, but now my applications can scale. I'm feeling quite proud of myself, quite impressed with myself. I'm starting to think, oh, I'm an architect. I can design a system. But the other thing that happens is that I start to see other AWS services, things that I'd never touched before, things that I'd never used before. What starts with just a load balancer and some target groups, well, it quickly progresses. Oh, I've got S3 over here. Oh, isn't that useful? I can store some data over here. That's just going to live outside of my application. I can access it if needs be, but don't need to worry about it. I've got RDS. I've got a managed service. I'm not going to have a database running on the same server as my applications anymore. I'm not going to have to go to the effort of actually standing up a database. SQS, one of the earliest services. In fact, I think the earliest service. Excuse me. I can introduce queuing into my apps. This is fantastic. And it comes back to that idea, that democratization of technology. All of a sudden, things that cost money, a load balancer in a data center, that costs money. Well, I'm not going to pay for that. I'm not going to spend my time I've not got my spare time to throw however much money at setting up a load balancer and playing around and seeing what I can do. Whereas now I can. I can create a test AWS account. I can click a few buttons. I can do a few things. I can run up a bill for hundreds of dollars, and I can contact AWS on the Monday and say, sorry, can you refund me? And they have to, and they did. So, where are we? We should catch up. So, obviously, even though I'm kind of moving into AWS, I'm still doing teams are still doing everything. We're still building our applications. We're still in control of everything we're doing. Now, when you're doing that, when you're working in teams, when you're working with long-standing applications, they develop quirks. They develop things that perhaps don't work as we would expect or were designed when they first started out. Or we may have had a team member who joined, did something, left. Documentation never existed. No one knows how it works, but it works, so we leave it there. And it just carries on. And as long as it doesn't break, we don't worry. Now, this brings me on to one of my bugbears when people talk about serverless, and the idea that serverless is complicated, it's complex, you're adding complexity to your applications. And my response to that is, well, complexity exists. It doesn't go away, but it's baked into applications. You can't see it. You need to know it. You need to understand what it's doing. And like I say, as those things grow, as teams grow, as applications develop, that knowledge disappears, floats away. Now with serverless, that complexity exists, but it exists in the open. You can see what you're doing. You can see how you plug those services together, and you can see what interactions they have with each other. So the point I'm trying to get to is that, I'll never stop learning. You'll never stop learning. We're always going to be learning new ways to crack old nuts. I know a lot more now than I did at any of those stages, but I also know I'm still on a journey, and I want to get better at what I do. So there's a whistle-stop tour of me and how I've come to embrace and love serverless. And now we'll actually crack on with looking, well, how can we build something without writing any code? So for our example, I'm going to keep it nice and simple. Now, at the heart of most applications, you've got two ends. You've got a data store over here, and you've got users over here. You want your users to read and write from that data store. Fairly simple. What we do is we add value to that transaction. We make it more interesting. We do stuff. If all we're ever going to do is read and write to databases with nothing in between, there's not a great deal for us to do. So I'm going to demonstrate how we can add value to this transaction by creating a very, very simple job board. So what we'll do is we'll start with data. Start over here. We need somewhere for our data to live. I imagine almost everyone in this room is going to know DynamoDB if they've not already worked with it. It's a fully managed serverless key value NoSQL database. We're going to create a table, if you can see that. We're only kind of really interested in how we're going to key that data. But as we create our table, we're not really bothered about the keys. We'll just call it a primary key and a sort key. What we're interested in with DynamoDB is how we're going to use that to access our data, what our access patterns are. Obviously, quite a brief description of what you can do with Dynamo. You can do an awful lot more, but we don't need to be opinionated. We call it a PKSK, and we'll deal with how we're going to use that later. So now we've got a durable data store we don't need to think about. I'm not saying we shouldn't think about it, but we don't. It's sitting there. It's serverless. We don't have to do anything with it. If we've got nothing in it, it's not costing us anything. We can configure backups, we can do point-in-time restoration later, but at the moment, we don't need anything. So on the flip side, the other end of the equation, use API Gateway. So API Gateway, so fully managed serverless service again, handles all you need to, it's handled with accepting up to hundreds of thousands concurrent API calls. There's a few other things, I'll not give that away just yet. But you know, we can use this as our interface to our backend services. So now we've got these two things. What we need to do is start working out, well, how are we going to access that API? How are we going to access that data? So we can abstract our routing logic to API. So where we might be abstracting it to a routing service in a framework, well, let's just lift that out another layer. We'll abstract it to API Gateway. So we can create our resources, we can create our methods on those resources, and after creating them, we can get a nice static response. So as you can see here, I've mapped a 200 hello world, job done. We've got an API returning data. Now, the beauty of creating static responses, and I don't think it's something that should be overlooked. It's a very quick step, it's a very quick thing you can do. But generally, and hopefully, when we're building APIs, we are building them to some kind of documentation. If we're lucky, we've actually got a proper API spec, and we know how that API needs to run, how it needs to work, and how it needs to interact with our data. So we can mock all our responses for that API, and we can say, right, we've stood up the front end of it. Front end team over there, take your crayons out of your mouth. You can now start interacting with our service. You're going to be getting static data back, but if I do my job right and I build my backend services in the way that is described in the API, you're going to get the same response, but it's going to be dynamic. You're going to get more from it. So as you develop your backend services, you can have your own little kind of strangler pattern as you bring things online. You can replace services as they come up with your dynamic ones, make sure that it works, make sure it tests, and off you go. So, obviously, that's great, but we've still got this data over here that we want to be writing to, we want to be reading from. So originally then, this is where we have our integration options, and where we're going to perform those CRUD operations. Now, there are lots of different ways we can interact between API Gateway and DynamoDB, but we want to be Lambda-less, we want to keep it simple. So what we can look at are the AWS service integrations. Now, as you can see, there are lots and lots and lots of native service integrations. So what that's going to do is just plug the two things together. We don't need to think about Lambda at all. So if we take our post method, we can select DynamoDB as our service we wish to integrate with. And then what we're going to do is, again, what we do in code often. We're going to configure a region. We're going to configure a service. We're going to configure a method. We're going to configure an action. These are things that you would be doing in code. But again, we've lifted them out when we're doing them over here. Now, the other thing that I like here to point out is we've got our execution role. Now, that's an execution role on the method. So much like you're going to create roles for your compute instances, so EC2, Lambda, whatever it is, you can actually create a role for your method execution. The beauty of creating a role for a specific method execution is then you can scope that IAM down to really lock it down to what it can and can't do. So if you think about test-driven development, we should know what a function is going to do before we write it. We know what we expect it to do. We know what we expect it to handle. It's a similar thing if you think about scoping your IAM permissions. I know I want to be able to write to a DynamoDB table here. I also know there are lots of things I don't want it to be able to do. And it adds another layer of protecting me from screwing things up. Because say I had put a Lambda in here and I completely misconfigured it and essentially deployed the wrong Lambda to the wrong endpoint, who knows what havoc I could cause? Well, if I've scoped my IAM, that's going to block me. That's going to stop me from causing the issue. So once we've configured the service integration, we just need to map that data. Excuse me, if you look at the map we have here, you'll see, that should be familiar to you if any of you do work with, or other people who do work with Dynamo. So you're essentially creating those insert parameters there. We're using the request context to give ourselves a UUID. If anybody knows that, I shouldn't have done that because I know I shouldn't have done that. Let's just keep it to yourselves. There's a proper way of doing that, but anyway, we ignore that for now. And we can test our endpoint, and we can insert a record into our database. So now we've got that interaction between our users and our database. We've got no code whatsoever. We're just configuring services. So next, we want to look at then obviously retrieving data from that database. And it essentially follows the very similar pattern as we had before. We configure regions, we configure actions, and this time we're querying and we're returning the data. Now, the difference we have here is obviously when that data comes back from Lambda, it's in its beautiful Lambda JSON. So we've got the types on the fields, and essentially API. Generally we're not going to look for that in an API. So what we can do is use VTL on our integration response, and we can map that data and we can sanitize it. We can essentially make it look nice for our APIs when they get consumed. Now, what I could do is go through every single method and essentially repeat what I've done. But I'm going to save you that thrilling part of the talk, and we can move on. I think we can say, right, great, we're interacting with DynamoDB. We've not written any code. Great, we've stood up an API. So, brilliant. Job done. I can retire. You can take some time back, although we were a bit late starting. We've got a serverless data store. We've got a simple API that reads and writes to it. It scales. It's got redundancy. Not written a line of code. Super. But Tom, I hear you all cry, or assume I would hear you cry if someone did. This is a rubbish API. What happens if we need to authenticate our requests? Well, you can't. What happens if someone floods our API with requests and tries to do some kind of cost-based denial of service? Well, yeah, it'll be a problem. What happens if people send malformed data? Well, yeah, it's going to be malformed. Okay, so it does a job, but it doesn't do a great job. So let's see what else we can do. So they're all valid points. So let's start with securing our API. So we've got our job board. And if you think, those GET requests, we're quite happy for people. We want people to get the jobs from our job board. We want them to read that GET method on our jobs endpoint. What we really don't want to do, though, is have people flooding our job board with dodgy posts, weird jobs, trying to, get candidates to apply for things that don't exist. So it'd be a good idea to, authorize those calls. Be nice to throttle the API. Like I say, at the moment, we're working with a proof of concept. We know we're not going to get much traffic. We know that if we do get a lot of traffic, we shouldn't be getting a lot of traffic. And we also know this will, likely to be, it's malicious. It's something very much gone wrong, and it could result in a nice bill at the end of the month. So it'd be great to throttle those requests. It'd be really nice to add other security controls which you might add in your application, the various packages, dependencies you can install that will harden your applications against, again, malicious actors or script kiddies, anyone who's looking to do something a bit nefarious. So we'll start with Cognito. Cognito, again, I'll not really delve into, but it's AWS's OR service, very easy to configure. Importantly for us here, it's also very, very easy to configure and integrate with other AWS services. So we can create a user pool, add users. We can, we could add additional identity providers, could modify the claims that come back in the JWT. We could build workflows around that sign-in, sign-up process. We're not going to, but we could. All those things are ready for us to go. And so once we've got our user pool, we create the authorizer in API Gateway. That is the right one. I actually see my screen. So once we create the authorizer in our API Gateway, we just add it to the method request. So we can do it method by method. We don't have to secure the entire endpoint. We can just do it method by method. It's simply going to require a bearer token in the header for future requests. Anything that we don't get, if it's not received, it'll be rejected. That token is going to be validated against our Cognito, make sure that it's not been tampered with, it's not malformed, make sure that it's not expired. So we've secured our endpoints now, and we've still not written any code. So on top of that, like I say, it's a good idea to stop people messing with things, messing with APIs, people you don't want them to. So, again, but it could be malicious. It might just be people messing around. But what we can look at here is we can have some usage policies to our API. So we can really restrict the data people can send to it, the rate at which people can request from it. So again, we're not going to see skyrocketing bills in a proof of concept. So we create a plan, give it an API key, we associate it with the API, but then we pick and choose the endpoints with which we want to have that API key on. So great, now we've got a nice rate limiter, we've secured it, we can handle traffic spikes gracefully, and we can control costs. So, brilliantly, my slide deck and the speaker's notes don't tie up at the moment. So don't use Google Slides when you're doing a presentation. All right, let me find where I am. So, yeah, we've still got plan A for our. I hope I'm not shared the wrong slide deck with you, Jamie, because it would be a bit of a problem as we get further on. But we're fine.
Why don't you pop open whose laptop you got there?
Jamie's. It's fine. I'll just carry on.
Sure.
Yeah, we're all good. So we can use WAF to secure our API further. So it's a web application firewall that lets you monitor requests that are forwarded to your things like API gateway, CloudFront, load balancers. We can use a managed rule set, so we don't really have to think about it too much. There are quite a few managed rule sets that, as long as they come under a certain threshold, don't cost you anything. And then there are various paid-for rule sets that various security companies can give you. So now we've secured our API. The other thing we can do is we can put a whitelist, IP whitelist in front of it. So anything we're doing in dev, testing, staging, we don't want that exposed to the world. We don't want people falling upon it. We don't want people hunting it out. So let's just block that traffic before it hits. Great. I think we're back on track. So next problem we're going to solve is we've got our API, but anyone can write anything to that API. So I know that we all have excellent documentation for every application we work on, every project we've ever been involved in. And because we all have excellent documentation, everyone who's ever integrated with any of our APIs has done it perfectly. So we've never had any issues with malformed data. But in some rare circumstances, some rare cases, this doesn't apply. And there can be an edge case where that data just simply isn't right. So what we can do is we can lift and extract our data validation, again, out of our code into AWS. Really straightforward. You'll have done the same thing in code. We're going to create a JSON schema. We're going to define what fields are required, and we're going to scope what type of data we accept for those fields. We can tell our endpoint and our method that we want to validate the body, and then we can tie that schema to our body, and we can validate our data. Now, this is great for a number of reasons. Firstly, it just does what it needs to do. It's validating the data that's been sent to our API. They're validated against the schema, and that's it. It fits the bill. But secondly, and this kind of comes in if we aren't doing it serverless, if we aren't doing it Lambda-less, if we are having some compute, is that because we're now validating here at an API gateway level, we don't need to validate further downstream. So those Lambdas can become simpler, they can become smaller, and they can become quicker. They can be focused and scoped on exactly what they need to do once they've got the data that they need to have. So if you think back to the previous step with the authorizer, the same concept. We're taking that responsibility out of any code we may write, and we're putting it up here. So now can we say job done? We've got a secure redundant API. We're requiring auth on some endpoints. We're throttling requests. We've got a WAF in front of our API. We're validating data that's posted to our API. It cleanly reads and writes data to that data store. And I think that's pretty good, considering we've not done anything. We've not written any code. We've just thrown a few bits together. We've just configured some AWS services. It's all out in the open. You could log into the console. You can have a look. You can see what it's doing. You can see what is happening there. But I think we can do more. And obviously, the talk will be quite short if we didn't do any more. So where next? So at the moment, we've got this concept of administrators adding, editing, or manipulating those jobs, that data in the job board. Candidates can view it, but creating those jobs can be quite a laborious process. Single form, single API call, again and again and again and again and again. So wouldn't it be great if we could take a CSV of those jobs, put it somewhere, have it processed, and have it end up in our database? So when we originally did our integration with DynamoDB, we also, there's quite a lot of integration options. And you'll be delighted to hear, because I know I was when I was looking at this, S3 is one of them. So we can now take those requests or that posted data, that CSV file, we can handle it through API Gateway, and we can post it to an S3 bucket. Configuration, broadly the same as we had last time. Again, pay attention on your roles, make sure that you've got a scoped role to it, and you can upload that file straight into S3. Now, that's only the first part of it. Obviously, once it's in S3, it's not magically going to appear in our database. So this is where we can introduce EventBridge, and I know that there are going to be much better talks around event-driven architecture after me today. So I'd say, go to those and you'll actually learn properly how these things work and what they do. But EventBridge is it's a serverless event bus that enables us to basically quickly and easily integrate services and applications, both within our accounts, but then outside of our AWS accounts as well. So the idea of it like an event-driven architecture is everything's loosely coupled. We respond to events, we emit events, and we respond to them. We aren't limited to a single downstream application responding to that event. We could have any number of things respond to it. And those applications we build, essentially we can keep them simple, because again, we know our events, we know what's happening, we know what they need to do. Well, let's not overcomplicate it. Let's throw some of that complexity up here, and let's make our applications really simple. Let's make any code that we would write, really lightweight, really small. So, core idea of EventBridge is you've got your producer and your consumer. So in our instance, the producer for our event is going to be S3. So we need to know when something happens in S3, and that's something being a file upload. So firstly, we just toggle a switch. Now, obviously, this is all being done ClickOps. We wouldn't do this in the real world, but we just toggle a switch. And now those events are going to be broadcast to our event bus. So what we need to do is rewrite a rule in our in EventBridge, in our event bus, to look out for those events, that we can do something with them. As you can see, we've got a few lines of hesitate to call it code here, Jason here, where we've got that pattern matching against what is happening in that specific bucket where we're looking for a put item event. So we need to send it somewhere. It's no good now. We've uploaded our file. We've broadcast that we've uploaded our file, but now we need to do something with it. So this is where we bring in step functions. Now, step functions, I love step functions. It's a serverless orchestration service based on state machines and tasks. Now, there's a very old diagram here that gives an example of a step function workflow. Now, there are many more newer and better ones, but the reason I've included this is because it was part of this paper. It was this diagram and this paper that really kind of awakened me and opened my eyes to think, you know what? I think they're onto something here. So we've got that familiar transaction we talked about. On the left-hand side, we've got a user, we've got an API gateway. On the right-hand side, we've got a data store. What we're doing, we're putting data from one end to the other. But then what we're doing in the middle is that value adding, that thing that's useful. And here we're doing it with a step function workflow. Now, I'd say at the same time, this process is very simple, but also complex. So each function is single purpose, performs a very simple single task. If it succeeds, it progresses to the next. If it fails, we capture that failure and we undo anything that we've done before that needs undoing now. So in this case, it's around a kind of travel concept. So you've got car rental, flight books, I think hotel reservation. Any one of those steps fails, we need to undo the others because we don't need a car in a city we're not going to visit. We don't need a hotel room in a place we can't fly to. So again, it comes back to that complexity. There's complexity there in doing it, but we've done it out here in the open. Our code we've written is actually really, really simple. The pattern that we've used, it's clever, it does good things, but the code we've got is really simple. Now, if you flip that round and think, okay, how would I write that in code? How would I do this in application? You think, the requirements here are straightforward. Think about coding it. Think about how you're going to handle those failure errors. Think about how you're going to understand where you are in the flow so that you can undo some of the things you've done. Think about testing it. Think about having that visibility of where the failure lies. Here, we get a failure in the first step. We can see it visually. You can sell it to your PMs. You can sell it to your bosses because they love a diagram. They love imagery. It's really easy to see. So the other good thing about step functions is you get loads of love from AWS. It's definitely not one of the unloved sons of the AWS service world. So they've been developing it. They've been adding new services, new integrations over the years since it has been released. We've now got a lovely workflow studio where you can design your state machine. There are also flow states you can use where you can kind of have choices based on previous steps. You can have parallel executions, past states where you can transform some of the data that's being fed through. You can wait for things. You can expect tokens back. Lots of really useful, wonderful things. It's also got, I think, over 200 service integrations. So if we think about what we're trying to achieve, let's see if we've got a service integration with DynamoDB. I'm pretty sure we will. So we've got our step function that's invoked by the upload of the CSV to an S3 bucket. Wouldn't it be great if we can now process that CSV line by line and insert that data into our database? So, as I mentioned before, we've got those additional kind of states that exist within step functions now. One of those is distributed map. So what distributed map does is that will take a CSV file. My eyesight isn't good enough, but essentially what you should be able to see here is that, so this has been invoked by our event bus. So it's responding to that event. That is giving it the details of the bucket and the key for the object that's caused the event. So what we can do is tell this, right, go to that S3 bucket, go to that keyed object and process the CSV data that is in there. And then the next thing we do, so again, I think all the documentation I've seen, you'll see a Lambda function that will then insert that data into DynamoDB. Well, again, we don't want Lambdas, we don't want any code. Let's see what we can do. Great, we've got our native service integration between DynamoDB and step functions. So I can now process that. I just map the data that I've got from my distributed map, and I map it to my insert state, well, my insert parameters, and we've inserted our data into the database. So now we've got a facility to upload data into S3. We've got an event emitted on that upload. We've got a rule in place to capture that event and forward it to our step function. The step function will take the object from the bucket, it'll loop through the data in the CSV, insert the records into the database, and we've still not written a single line of code. So slowly but surely, we're building a back-end application and we're not writing anything. We're just using AWS native services. Now, it's not glamorous what I've created. And you'll see lots of really good and fascinating, interesting talks that show you some of the really kind of interesting, sexy AWS services. But the point is, most of us will be dealing with CRUD applications day in, day out. Most of us will be writing things that look fairly similar to what we've done. So if we're now aware that we've got the opportunity to say, well, let's lift some of that responsibility somewhere else. Let us focus on what we can do to add value to that. Now, like I say, we've kind of just scraped the surface. Not only would Phil not let me go on all day, but to be honest, I don't want to. I'm happy to sit down after this, have some lunch and maybe a beer. But we've not looked at any logging, we've not looked at any monitoring. There's all kinds of things we could do around that where we could enable logs on our API gateway. The logging we get from our step functions, the logging we can get from Event Bridge, where we can build our own dashboards. We can get insight into how our applications are working. We can create alarms on failures. We can see what the problems are. Like I say, this demonstration was all ClickOps, but we could use SAM for all of this. We could use serverless. We could use a number of services. We could then build that into a serverless deployment method where we're using code pipeline, code build. We could plug step functions into that process, so we could perform integration tests before we actually say, no, we're good to go. There's so much, so many services just at our fingertips that we just need to have the time to do a proof of concept for. So, takeaways from the talk. Well, have I ever done this in prod? Well, no, not that exactly. But every single part of that I have used in prod in some way or another. And this is the important part, is that all those things are interchangeable. You can stand up that proof of concept very quickly without writing any code that performs the task you want it to perform. When you then revisit it and look at it again and say, well, actually, my authorizer just isn't good enough. It's not good enough for me to know that someone is in the user pool and that the token's valid. I need to do more than that. That's OK. Let's go and create a custom Lambda authorizer. And we can just swap that out. The rest of it stays the same. But again, we're focused, really focused on the detail of what we need to do to achieve that next business goal, to achieve that thing we're looking to do, rather than just being confronted with an application that does everything. So yeah, as a team, as an architect, you can start to make decisions. You can start to focus your time and effort on where you think, well, actually, we're going to get the most value for me, my team, in doing this. We'll throw that over there, we'll throw that to AWS, and we'll focus on what we want to do. Now, the other thing is that you are still in control. Yes, you've abstracted a lot of that to AWS, but you're still in control of it. You've still configured it. It's still your application. It's not a point and click, there's an API. You know what the API is doing. You know how it's communicating with your databases. It's the same as abstracting it to a package or something else. You're still configuring that. You know what you're doing. You're just like I say, you're handing that responsibility just a bit further up the tree. So, thank you. Thank you for waiting, because obviously we had a bit of an issue with the tech. It's really great over the past couple of years, I've become more and more involved in the AWS community, and it's a fantastic community to be part of. I really appreciate every one of you who's actually come along to see this, because there's an awful lot happening, an awful lot of options. So thank you for coming. If you liked it, please connect with me on LinkedIn. I'll be floating around at the community stage, or community table, sorry. I'll be staying for whatever the afters are later. If you didn't like it, you can perhaps keep that to yourself. I've got a very fragile ego. 2 more things. I've got 2 plugs. Okay, thank you. 2 plugs. So firstly, I run AWS Sheffield. So if you come over the Pennines and you want to come to your local user group, again, scan the code, join it there, or get in touch with me afterwards. And lastly, we're at Birmingham Tech Week in Birmingham. Thanks. On the 17th of October. And we'll be giving a talk with Sperry Rail, who are one of our customers, and we'll be going through their journey in AWS. We'll be talking about some of the services I've touched on today, but mainly how they're using ML and AI to make the world's railways a safer place. Thank you for your time.